All right. So 7b is about applying what you did in part A, 7a, in the context of simple interest. So we haven't looked at finance at all this year, and I think the last time we looked at finance, if you were in my class last year, was probably term 3. All right. So what I'm actually going to do is I'm actually just going to do an example with you. Okay. So I'm literally going to do question 2 for you. Yeah. And as I work through the question, I'm going to discuss some things with you. So, um, in this question, we are told we've got $8,000 in an account. And I'm guessing most of you have bank accounts now at your age. You might not earn interest. Do you earn interest? You do? So if you don't, change bank. Go with one that gives you interest, like ING or something. Yeah, it is. Okay. Now, last year, so pay attention, guys. Tom, Harry, please listen to this. Last year, we treated finance and recursion separately. They were completely different topics. We didn't merge the two together. This year, they are integrated. So everything that we do in finance, we're going to analyze with recurrence relations this year. Okay, so you might think simple interest, I'm going to use the I equals PRC over 100 formula. We're not going to do that this year. Okay, we're just going to use recursion. So let me just quickly write down what we're asked to do in this question. So first state V naught, and then B and C. I'll just combine B and C together as write down a recurrence relation.
Because you're not here.
Let's just leave it on the desk.
Have you know that Jenny coming back out?
Okay, so my guess, so what I'm thinking is none of you have actually answered a question like this before because we never did finance with recursion. So I think I've got some explaining to do here. All right, so the first question I'm going to pose to the class is, what's the difference between simple interest and compound interest?
One is it grows.
What's growing though?
The
You're on the right track, Cooper.
Isn't simple interest where it goes up by the same amount, whereas compound it goes up by a certain percentage of the amount from the last.
That's it. Okay. So simple interest doesn't really happen in the real world. But if you were to choose between simple interest and compound interest for your own savings, you'd always choose compound interest. Because simple interest, they calculate the amount at the beginning and they give you the same amount of interest, regardless of how large your savings account is. So I'm going to write down two recurrence relations for you, and only one of them is going to be correct. So Jazz, I'm going to write down two recurrence relations, and I want you to tell me which one you want to use. So here, D is just a number. And R is just a number here. So we're only going to use one of these, and here your choice will demonstrate to me whether you understand simple interest or not. So Cooper has just said we're going to model simple interest by adding the same amount each time. So which one?
Can you not do this?
No, but like, how can you add the same amount every time you time?
That's a good point.
It's gotta be if you're adding by the same number, it's gotta be the first one.
Good. So notice the key word. We are adding the same amount each year. So my recurrence relation is going to involve addition, where d is going to be some number which I need to calculate based on the interest rate. Okay, I haven't done that yet. Compound interest, we're going to multiply by some number slightly larger than 1. And that's going to be the value r. That's coming later. Okay, so I'll just give this to you up front. Do I add or do I multiply in the recurrence relation? With simple interest, you're going to add. With compound interest, which is tomorrow, we'll multiply. Okay, so we're nearly there. We've set up a recurrence relation where we're adding some number capital D. That's just a symbol your textbook uses. And now I need to decide what that value is going to be. So we agree that in simple interest, we add the same amount each year. But what is the number itself going to be? How much are we going to add to the account? You're going to need to look at the information in the question here.
0.4 times.
0.4 is 0.4 needs, you need to adjust the number 0.4 very slightly.
0.04.
Why is it 0.04?
Because 0.4 is 40%. It's 40.
Good. All right. So I'm going to give you a formula, okay? If your interest rate is R, so here I'm going to define R equals 4, because it's 4% per year. So if you do this, the amount that you add each year when using simple interest is R% of the amount in the account at the beginning. It's not 8,000, V0. V0. Okay, so R over 100 means R%. This means R%. And V0 is how much you have at the beginning. Does the orange equation make sense, or have I just lost you?
Yeah, it makes sense.
Okay, can you explain it to me?
Yeah.
Okay, I'm not here, so I've forgotten everything. You need to explain the equation.
It equals the rate over 100 times whatever it is.
Times by the amount of capital.
Okay, why are we doing that though? Why are you multiplying?
To get the number,
interest.
so you can work out the simple interest.
To get the percent of the price.
Why do we use V naughts? Yeah, so simple interest is always calculated using the amount at the beginning. So the longer you let your simple interest run, the less value it gives you. Yeah? Because let's say I ran this for like 50 years, I would have thousands of dollars more, but I still have the same amount each year coming in as I did at the beginning.
So theoretically, if you started with like $1 million, I'll do that.
Yeah. But as it grows, the ratio of the interest to your actual amount in the account goes down.
Yeah.
So eventually
You get to zero.
this is like nothing after a while. Okay? So Let's see. What do I do? Purple.
Compound interest, what you want.
Compound interest is what you want if you're the one making money.
Yeah.
Okay. All right. So
All back compound.
what's V naught going to be?
I guess.
Good. Obvious question, but it needs to be said. V naught is the amount in the account at the beginning. So Vn plus 1 equals Vn plus 4% of 800. You can do the calculation, it's 320. Okay? Now, is this a recurrence relation?
No.
Why not?
Because it's no.
It's not a recurrence relation yet. I'm missing, remember, you need two pieces, you need the starting point. So this has happened on an exam. So on the exam, they ask, write down a recurrence relation. And a lot of people will just give the second part, because that's the pattern, right? That's the part that you're interested in. But you must provide both equations. You must tell me V naught. You must tell me how to get Vn plus 1 from Vn. If you don't do both, you don't have a complete recurrence relation. And based on past exams, this is a 1 mark question, giving both. And if you only give one, you'll get 0. So make sure that you put both down when asked for a recurrence relation. So I also need to say V naught equals 8,000. And then I've answered the question. Okay? Would you like me to do one more?
Right, is this what we learned last year?
Except we didn't use the recurrence relation.
Yeah, now it's all packaged with arithmetic sequences and recurrence relations now. Okay, so with recursion and finite were separate topics last year. Now they're integrated. Okay? Yeah. All right. I'll leave it there, and I'll do one more example combining both 7b and 7c at the end of the lesson. So why don't you finish off 7a and try to start 7b today if you can.